So I want you to picture a tightrope walker, right? Just suspended hundreds of feet in the air.
Oh boy, okay. Setting the scene.
Yeah, I mean, you have to visualize it because on one end of this rope, you have this idea of absolute, just uncompromising sovereignty over your money.
Right, the holy grail of crypto.
Exactly. We're talking stateless, trustless, completely air-gapped architecture where you and only you are the master of your wealth. But, the walk to get there is, well, it's brutal.
That's full of friction, yeah.
Right. You're dealing with like complex multi-sig setups. You have to manage your UTXOs and physically secure these metal seed phrase backups. It's a lot.
It is a lot for a beginner.
But then you look at the other end of the rope and you have effortless simplicity. Like a system so seamless, you basically just tap your phone and you're onboarded.
But traditionally, getting that level of UX means you have to give something up.
Yes, you have to compromise. You're either handing over some trust to a third party or, the hardware is hidden behind this closed source corporate wall.
Yeah, I mean, honestly, it is the defining tension in digital finance right now.
Totally.
Balancing that extreme verifiable security with a user experience that doesn't feel like you're taking a final exam in applied cryptography. It's a puzzle developers have literally been trying to solve since the Genesis block.
And that is exactly what we're getting into today. Because what we're looking at is a conceptual document that basically says, you know what, we refuse to compromise on either side of that tightrope.
Which is incredibly ambitious.
Oh, it's wild. We are taking a deep dive into a document that's just titled Hardware Wallet Concept Brainstorm.
Very understated title for what it actually is.
Super understated, because it's essentially this massive blueprint for a Bitcoin-first hardware wallet, and it aims to pull off what most people in the space consider to be an impossible trifecta.
Right. They are explicitly trying to merge three completely different design philosophies into one device.
Yeah, the document outlines wanting the frictionless, NFC tap simplicity of a Tangem card.
Which is great for UX, but closed source.
Right. And then combine that with the open source, heavily audited architecture of a Trezor device.
Which gives you transparency.
Exactly. And then, as if that wasn't enough, they want the absolute hardcore stateless sovereignty of something like a seed signer.
I mean, attempting to forge those three distinct ideas into a single cohesive piece of hardware, it's a monumental engineering challenge.
Okay, let's unpack this, because the document frames this whole challenge with a central mantra that I think it perfectly captures what they're going for.
The Bruce Lee quote.
Yes, the core philosophy of this device has to be, quote, Bruce Lee security, Mr. Miyagi simplicity.
That framing is just so crucial to understand, because when they talk about Mr. Miyagi's simplicity, they're directly attacking the onboarding friction that keeps everyday people out of self-custody.
Because right now, onboarding is intimidating. I mean, if you look at traditional cold storage, you buy a device, and immediately you're hit with the 12 to 24-word seed phrase.
Then you're told to guard it with your life.
Literally. You have to englave it into steel plates, hide it in multiple physical locations.
It's like trying to build your own bank vault from scratch in your garage.
Exactly. That is a perfect way to put it. You're building a vault. Whereas this concept, they're saying onboarding should feel as simple as, setting up a new smartphone.
Right, or just tapping a credit card.
Yeah, they want to mask all that terrifying cryptography behind an intuitive interface without actually, downgrading the math itself.
What's fascinating here is how they address the psychological barrier. Because if we actually want people to take control of their digital wealth, you have to remove the intimidation factor.
Because if you don't...
If the user experience is too complex, people will just default to leaving their money on centralized exchanges.
Which completely defeats the entire purpose of Bitcoin.
Completely. But this concept, it aims to fix that. But I know you had some reservations about this abstraction.
I do. It raises a massive red flag for me. If the goal is absolute sovereignty, doesn't hiding the complexity from the user create blind spots?
How do you mean?
Well, if I'm not the one managing my derivation paths and I'm not actively checking my UTXOs, I have to rely on the software to do it for me. And if the software is doing the heavy lifting, I am trusting a software developer.
I see where you're going. You're worried it devolves back into a trusted third-party situation.
Exactly. Did we just rebuild the bank?
Well, the document proposes solving that exact paradox in a really clever way.
Yeah.
They aren't suggesting we hide the mechanics permanently.
Okay.
They're suggesting an ecosystem that essentially scales dynamically with your technical competence.
Oh, interesting. So it grows with you.
Right. So the blueprint proposes a companion mobile app designed for that immediate Tangem-style ease of use. It's for your everyday interactions, initial onboarding. It handles the heavy lifting visually.
So for a total beginner, it's just a clean, easy-to-use app on their phone.
Yes, but, and this is the critical part, the hardware itself isn't locked into that beginner app. The document explicitly mandates that out of the box, the device must be compatible with highly advanced, sovereignty-focused desktop software.
Like Sparrow or Nunchuck.
Exactly. Sparrow, Nunchuck, Blockstream Green.
So it's basically a hardware layer that speaks both languages.
Exactly.
If you're a beginner, you interact through a polished mobile UI that abstracts all the noise. But like, say you spend a year down the rabbit hole and you transition into a power user.
You don't have to go buy a new, more complicated hardware wallet.
You just take that exact same physical device, ditch the beginner app, and plug it into a heavy-duty desktop coordinator to build, like, your own complex multi-sig quorums.
Precisely. And the device features clear, high-resolution visual confirmation screens directly on the hardware.
Oh, so you weren't just trusting your phone screen.
Right. Even if you're using the simplified mobile app, you are verifying the exact destination address and the network fee on the physically isolated hardware screen before you ever sign the transaction.
Okay, that makes sense. Which naturally leads us to how this physical device actually protects the keys. Because, I mean, let's be honest, all the sleek UX in the world doesn't matter if the vault has a backdoor.
Right, the Bruce Lee security side of the equation.
Let's get into that. Because the document mandates this strict offline-first design philosophy. They explicitly state there should be absolutely no unnecessary wireless features.
None. Zero.
But, I mean, stripping out Bluetooth and Wi-Fi?
Yeah.
In the modern era, that feels like a massive step backwards for user experience.
It sounds clunky at first, yeah.
Right, like if we're aiming for mobile companion app simplicity, how are they actually communicating with the phone? Are we talking about scanning clunky QR codes or like carrying physical cables everywhere?
Well, the blueprint leans heavily into two things. Controlled NFC, so near-field communication, and high-density animated QR codes.
Okay, so tap-to-pay style or camera scanning?
Exactly, because the air gap is non-negotiable for true sovereignty. Every wireless protocol, whether it's Bluetooth, Wi-Fi, cellular communication, they all have massive attack surfaces.
They're always listening, right?
Yes, they're continuously broadcasting, listening, executing these complex protocol handshakes, and historically, those are notoriously vulnerable to remote code execution exploits.
So by limiting communications strictly to optical QR scanning, or just that momentary proximity-based NFC, you are enforcing a physical air gap.
The device becomes mathematically and physically isolated from any internet-connected malware.
Right. If some state-sponsored hacker wants your keys, they can't just sit in a van outside your house and ping your Bluetooth receiver.
No, they literally have to break in and physically hold the device in their hands.
But even if they do manage to physically steal it, the hardware architecture outlined in this brainstorm is just, it's aggressive.
Oh, it's intense.
They call for, quote, strong physical tamper resistance. And we aren't just talking about, like, a tough plastic shell that you can't pry open with a screwdriver.
No, they are anticipating a threat model where an attacker might try to decapsulate the silicon chip using highly corrosive acid.
Acid.
Yeah, acid. To expose the memory and try to read the state using an electron microscope.
That is wild.
Which is exactly why the physical architecture requires epoxy-potted secure elements and these anti-tamper meshes built directly into the circuitry.
So the device knows if it's being messed with.
Right. If the hardware detects a voltage anomaly or a physical intrusion or an attempt to bypass the bootloader, it is designed to essentially brick itself.
It just self-destructs.
Basically, it instantly zeroes out the cryptographic material before the attacker can extract it. And the document specifies this must be designed for inheritance.
Meaning what, exactly?
Meaning it needs the physical robustness to sit in a safety deposit box for 30 years and still function perfectly when your heirs go to access it.
Okay, but this actually brings up my biggest point of contention with the entire document.
Oh, yeah.
Alongside this impenetrable, acid-resistant physical security, they are fiercely demanding an open, auditable design.
The Trezor model.
Right. They want the hardware schematics and the software code to be entirely public. But, okay, if you publish the exact blueprints of your physical tamper resistance mechanisms and your cryptographic logic, aren't you just handing a treasure map to the attackers?
You're showing them where the tripwires are.
Exactly. Isn't it safer to keep the security architecture a secret?
It is a totally valid concern. And honestly, it gets to the heart of a massive, ongoing debate in cybersecurity. Open source versus security through obscurity.
Okay, break that down for me.
So, security through obscurity assumes that a locked door is safer if no one knows what brand of lock is on it.
Which kind of makes sense intuitively.
It does. The problem is, highly motivated, well-funded attackers like advanced persistent threat groups, they will reverse engineer the closed source hardware eventually.
Oh, so they figure out the lock anyway.
Always. And when they find a vulnerability in a closed system, they exploit it silently. Only the attackers know the vault is compromised.
Wow. While the manufacturer is still putting out press releases telling everyone their money is perfectly safe.
Exactly. The open and audible design philosophy takes the opposite approach. It treats the security architecture like a public math equation.
Relying on Linus's law, right? Given enough eyeballs, all bugs are shallow.
You got it. It's the difference between hiding your wealth behind a proprietary padlock where only a small corporate engineering team has the blueprint versus securing it with an open cryptographic algorithm that every PhD security researcher on Earth has relentlessly tried and failed to break.
Right. When it's auditable, you have thousands of the good guys inspecting it.
Exactly. You are relying on verifiable math and the collective scrutiny of the global security community, rather than just the blind trust of a single company's NDAs.
And what's really cool is the document pushes that demand for verifiable math all the way down to the user level.
The entropy generation.
Yes, they don't even want the user to have to trust the silicon to generate their private keys in the first place. They actually outline support for generating entropy, the true randomness used to create your wallet, using physical, real-world physics.
The dice and camera integration. This is such a brilliant nod to the seed signer philosophy.
It's incredible, because usually hardware wallets rely on an internal component called a TRNG, a true random number generator. It picks the incredibly large numbers that become your keys.
But if that silicon is flawed,
Or if it was maliciously compromised somewhere in the supply chain to generate predictable numbers, your wallet is compromised before you even take it out of the box.
so they remove that trust entirely.
Right. This concept proposes letting the user literally roll physical casino dice on their kitchen table and then scan the results with the device's onboard camera.
You are injecting chaotic real-world physics into your key generation. You don't have to trust the microchip. You verify the randomness with your own eyes and hands.
And that ties directly into their support for SeedQR, right?
Yeah, allowing users to store that physical backup as a machine-readable, hand-drawn QR code rather than a list of 24 words.
Which totally reduces the user error of inputting words manually on a tiny screen during a recovery process. It just perfectly maintains that tightrope balance, extreme security with Mr. Miyagi simplicity.
It really does. But, you know, we've built a formidable physical architecture here for today's threats.
Right. Hardware only stops today's attacks. And here's where it gets really interesting. Because the document outlines a security proposal to future-proof this vault that sounds completely like science fiction.
But the underlying mechanics make total sense.
They propose an architecture that minimizes or entirely eliminates firmware updates.
If we connect this to the bigger picture, eliminating firmware updates is arguably the most radical and important proposal in the entire document.
Because we're so used to updates.
Exactly. We have accepted across the tech industry that hardware requires constant patching. But in the context of cold storage, a firmware update is a glaring vulnerability.
Well, yeah, because it requires the user to break the air gap concept. I mean, to update it, you have to connect the device to an internet-connected machine, download a payload, and flash the memory of the secure element.
Right, and that introduces a massive vector for user error and supply chain attacks.
Like phishing.
Exactly. What if the user is targeted by a phishing campaign and downloads a malicious firmware package disguised as a critical update? Or worse, what if the manufacturer's own servers are compromised?
Oh, man. And the official update pushed to thousands of users contains a hidden backdoor.
Exactly. By designing a device that never needs a firmware update, you completely close off those attack vectors. The device becomes a static, immutable fortress.
But how is that actually technically possible? I mean, if an exploit is discovered in the cryptographic signature process 3 years from now, you have to patch it, or the keys are vulnerable.
You achieve it through highly restricted instruction sets and immutable ROM read-only memory.
Okay, so the chip itself is fundamentally different.
Right. Instead of a general-purpose processor that can run complex, updatable operating systems, you design silicon, where the cryptographic operations are physically hard-coded into the logic gates.
Wow.
The chip can only do one thing: sign a Bitcoin transaction based on a highly specific, standardized input. If the chip physically cannot process arbitrary code, the attack surface shrinks to near zero.
But you still have to design that silicon perfectly from day one. You can't make a mistake.
Which brings us to the AI red teaming proposal.
Yes. To ensure the hardware doesn't need updates, the document proposes using dedicated artificial intelligence to essentially attack the architecture before it ever hits the manufacturing line.
They are talking about utilizing AI fuzzing algorithms against digital twins of the microchip.
So like a virtual laboratory.
Exactly. Instead of just relying on human engineers to spot flaws in the logic, they train an AI on every known side channel attack, power consumption anomaly, and electromagnetic leak.
It's like a team of automated hackers working 204/7.
This automated red team endlessly throws millions of theoretical hyper-complex attack vectors at the digital simulation of the silicon. It's actively trying to predict how quantum computing or advanced metallurgical attacks might evolve a decade from now.
So they let the AI find the zero-day exploits in a digital environment, which forces the architects to pour the concrete thicker, so to speak, before they ever print the physical circuit boards. But, okay, play devil's advocate. What if a truly novel threat does emerge 5 years down the line that the AI just didn't catch?
Then they don't issue a risky software patch. They simply release a version 2 of the physical hardware, incorporating the new defenses into the silicon itself.
Treating it like physical infrastructure.
It treats hardware wallets more like a physical gold vault. You don't try to digitally upgrade the lock on an old steel door. If the threats get advanced enough, you manufacture a stronger door. It forces a paradigm of getting it right the first time.
Okay, so we've achieved it. We have a mathematically verifiable, AI stress-tested, air-gapped vault that you can confidently lock in a safety deposit box for decades without ever updating the firmware.
The perfect fortress.
But wealth isn't just about hoarding digital gold in a bunker, right? It's about utility. If I have to jump through 10 security hoops, roll physical dice, and scan QR codes just to buy a coffee or pay a contractor, I'm simply not going to use it.
No one would.
Exactly. So what does this all mean? How does this concept bridge the gap between Fort Knox and a checking account?
This is where the brainstorm document moves from designing a neat gadget to designing a parallel financial system.
Oh, I love that phrase.
They propose a dual-layered approach for the ecosystem. You have the main vault device for your deeply secured Bitcoin savings, but they actively investigate integrating card-based spending, similar to Tangent Pay, directly into the same companion app architecture.
So keeping your life savings completely isolated and air-gapped, but utilizing an everyday spending card that carries a smaller, manageable balance.
Exactly. And they don't expect you to spend your Bitcoin on daily transactions because of the network fee constraints and, tax implications.
Right, buying coffee with Bitcoin gets complicated fast.
So they explicitly suggest researching deep integration with major stablecoins for this everyday spending layer.
This is a massive shift. So we are talking about keeping your Bitcoin perfectly secured as base layer savings, while seamlessly routing digital dollars like stablecoins running on layer 2 networks or side chains for your daily economic activity, all managed from the same non-custodial interface.
It's the true promise of digital sovereignty. And it raises an important question about the fundamental infrastructure of global commerce.
How so?
Well, the document actively compares this conceptual stablecoin hardware system against the traditional financial rails of Visa and MasterCard.
Because the legacy system is expensive.
Exactly. Right now, every time you tap a traditional credit card, a massive centralized intermediary network extracts a toll, usually 2 to 3% from the merchant. And the settlement takes days to clear between the acquiring and issuing banks.
But if you integrate stablecoins with an NFC-enabled hardware wallet card, the transaction doesn't route through a centralized bank server at all.
No, it routes directly over a decentralized network.
That is huge.
It signs the transaction locally on the hardware card, passes the signed data via NFC to the merchant's point-of-sale terminal, and the terminal broadcasts it to the network.
And the settlement.
Final in seconds. And the cryptographic fees are fractions of a cent.
So they are outlining a system that achieves this without sacrificing an ounce of convenience for the end user.
Exactly. If tapping a non-custodial hardware card at a grocery store feels exactly the same to you as tapping a Chase Visa card, but the merchant pays virtually zero interchange fees.
And you maintain absolute cryptographic custody of your funds right up until the exact millisecond of settlement.
You are fundamentally bypassing the legacy gatekeepers.
It is the tightrope perfectly walked. You have the fluid utility and instantaneous settlement of the legacy banking system, but absolutely none of the counterparty risk.
You don't have to ask a bank's permission to move your money.
Your account cannot be frozen by a centralized entity, and yet you don't need a computer science degree to go buy your groceries.
And that is the critical missing piece of the self-custody puzzle. I mean, we have had the cryptography to secure wealth for over a decade. What we have lacked is the hardware and software synthesis to make that cryptography invisible yet auditable to the average person.
So when you bring all of this together, what we are really looking at today isn't just a brainstorm for a sleek new crypto gadget.
Not at all.
It is a highly technical roadmap for consumer empowerment. It's about leveraging advanced manufacturing, immutable silicon, and AI red teaming, not just as marketing buzzwords, but as proactive tools to design physical hardware that feels completely effortless.
While remaining resilient against state-level attacks for decades.
Exactly. It is a vision where taking absolute mathematical control of your own digital wealth shifts from a nerve-wracking chore into an experience as mundane and easy as just tapping your phone.
It really highlights the inevitable trajectory of this space. The technology is finally maturing to a point where the friction is disappearing.
For everyone.
Yes, whether you are the kind of cypherpunk who insists on rolling physical dice to generate your keys, or someone who just wants to safely hold a little bit of digital value without trusting a centralized exchange. The architecture is bending toward giving you absolute control without the cognitive overload.
Which leaves us with a fascinating final thought to ponder as we wrap up today. We started by talking about walking the tightrope between security and simplicity. But if this document's vision actually materializes, if a secure, firmware-less hardware wallet ecosystem can seamlessly integrate stablecoins to offer a frictionless payment network that is objectively cheaper and faster than Visa or MasterCard,
It changes everything.
what happens to the traditional retail bank in a generation?
That's the million-dollar question.
If true self-custody becomes this seamless, and the rails for everyday commerce operate entirely outside the legacy system, do the physical bank branches that line our streets become completely obsolete?
Or will they have to adapt?
Right. Will these institutions be forced to radically reinvent what it means to provide financial services in a world where every single person has a central bank, a checking account, and a global payment processor sitting securely in their pocket? It seems the ground beneath that tightrope is finally shifting. Keep exploring, keep questioning, and we'll see you on the next deep dive.